and welcome to another episode of the Concrete Logik podcast. And today I have Dean Kraft with ISC Logik Industries. Dean, could you give us an introduction?
Thanks, Seth. Thanks. Well, like you said, my name is Dean Kraft. I'm one of the principals and owners of ISC Logik Industries. Our focus is to proactively address the issue of moisture vapor emission. So that's the residual moisture in the concrete coming out and causing issues with directly installed flooring, roofing, coatings. Been in the industry about 15 years. I think it's at least part of my background. I'm on the committees that writes the standards for flooring. It's the ASTM F6 committee on resilient flooring. Within that committee, I'm the technical author of a published standard that's already out and available, and it's for substrate surface porosity. I'm the technical author of a second standard that just got approved that should come to print here shortly. And I'm also on the ASTM D8 committee for roofing and waterproofing. And I have another standard working that way through now. It's getting ready to go out to full ballot. So not only are we a manufacturer, that we're really trying to also improve the industry overall on issues that affect trying to stick something to concrete.
Right. So let's explain what we're trying to prevent and achieve here. So we might not make a whole lot of flooring friends today. So let's explain to the audience why, first of all, why is it important to understand the moisture coming out of the concrete? Why is that important?
Well, if you look at the history, and it's funny, if you talk to, I won't say old timers because that probably applies to myself as well now. And it's a double-edged sword because a lot of the younger generation coming through, all they've known is the current situation of adhesives, low VOC. But if you go back over 30 years, that's when the glues took a significant change. So back in 1992, due to changes and scrutiny by the EPA, big concern arose over indoor air quality, IAQ, then became IEQ, indoor environmental quality issues. In other words, VOCs in the built environment harming us, leading to elevated elements or elemented cases of asthma, respiratory distress. So as it works in the built environment, one of the culprits was identified as the adhesives used to stick down flooring. So that was one of the first ones that really took a lot of scrutiny. So what occurred in 1992, there was a pretty fundamental and massive shift in the formulation of the adhesives. In other words, more basically, they went from a much higher VOC content adhesive to a water-based adhesive. And more simply, think about super glue. That would be a high VOC adhesive. It can basically cure in almost any kind of environment. And then think about Elmer's glue. That's a water-based adhesive. So if you're a woodworker and you're trying to work in high humidity environment, that wood glue is going to take a lot longer to set up than if you were using that same glue in, say, the high desert of Utah. Same glue, same wood, but the ambient conditions affect it differently. So long and short of it is, when the industry went from high VOC adhesives to low VOC adhesives, they changed the solvent. Water is the universal solvent. Water became the primary ingredient to allow that adhesive to spread. And the flooring system with the concrete, it does not handle it well if there's excess water. So that really drove the scrutiny on the moisture. What happened then? The installation instructions did not change. Massive failures occurred throughout the 90s. And then in 1998, the flooring industry, not the concrete industry, came up with the requirement the concrete had to be tested. So think that through. The flooring industry changed the adhesives, did not change the installation instructions, and then 6-7 years later, they turned around and pointed to the concrete. So that's the history of what happened. And unfortunately, like I said, we're talking 25, 30 years ago, and most people in the industry now do not know that.
Unintended consequences again hit the
yet, so think about this. Think about if you are like Elmer's glue. Elmer's glue is great glue, but if you use gobs and gobs of it with paper, it's going to create like a goopy mess. And now think about a glass tabletop, or in this world, think about power troweled concrete. You're going to get a nice sheen, it's going to tighten up the surface. That becomes a non-porous substrate. So if you're trying to glue something to that non-porous substrate, and resilient flooring is very, very thin, you can put glue down with a paint roller. But if you put too much glue down and then you lay down that resilient flooring, where does the excess moisture go? It has no place to go. It can't soak in the concrete. You've basically sealed the surface. And there is literature going back, again, 20 plus years that clearly shows that there is more than enough adhesive in some of these, water in some of these adhesives, that the water itself from the glue can induce the failure. So when they did not change the installation instructions and they kept applying these glues in high humidity environments or with the big notch trowel and put too much glue down, yeah, it was a moisture failure. The problem is nobody knows, was that a moisture failure from the concrete, or was it a moisture failure because there was too much water in the glue? That all got steamrolled. They focused on the concrete, and that leads us to where we are today.
Gotcha. So it sounds like glue is similar to concrete in the fact that concrete is a very locally based material, meaning that you got to think about the environment you're putting concrete in. Is the same for the
absolutely
the glue,
so,
the flooring. Yeah,
actually, it's a fantastic. So think about ACI 305, hot weather concrete practices, ACI 306, cold weather. One of the things, let's go back to concrete. Let's specifically ACI 305, hot weather. A lot of projects focus on, well, we're not above 80 or 85 degrees, so therefore we're not in hot weather conditions. But if you actually look at ACI 305, there is an evaporation calculation. Mm-hmm. So technically speaking, you could be at 40 degrees ambient, but if you got 20 mile an wind and you got no windbreak and you've got high, no cloud cover and you got low humidity, you better have an evaporation retarder out there. You better be taking steps to slow that evaporation rate, or the surface of that concrete is going to be compromised. And a lot of times projects don't take that into account, specifically with the cold weather, hot weather situation. They think, because it's another oft-repeated thing, well, hot weather's 80, 85 degrees or above. If you read 305 carefully, it's really driven towards evaporation rate. And it's the ambient conditions that drive that. So just like flooring, it's the ambient conditions that are going to drive specifically the proper curing of a water-based product. Like the example I gave for the woodworking. If you're in Central Florida where I live in August and you're in my garage, that glue ain't never going to dry. If we, jumped on the Star Trek transporter beam and took it to high desert of Utah, it's going to set up quick. All driven by ambient conditions. But if you ignore that, it can lead to, again, just like concrete. If you ignore the simple ambient conditions, ambient temp, ambient humidity, wind speed, substrate temperature or the ground with concrete, it could lead to some really bad situations. So your parallel with concrete is very similar with adhesive. Very similar.
Yeah. So let's talk about a typical project as far as, I guess, if we were doing it the traditional way, and then we'll get into other ways to tackle this, but in the traditional construction method, we would go out there and we would put the concrete down, the full structure, or concrete on top of metal deck or whatever. And then there's a process that we got to go through after the concrete's put down to prepare that concrete substrate for the flooring. Say we're putting flooring down on top of it in an office building or multifamily or
right.
Hospital's big one, right?
Yeah, schools.
Like schools. Can you walk us through what that traditionally looks like, and then we can talk a little bit about the issues that
sure, absolutely
occur on every project?
Absolutely. And actually, before I begin, we were talking before. I want to bring up something that you said. In your experience in history, what have you noticed in the specs, like in every single project? What have you noticed regarding this issue?
Oh, okay. Yeah. Well, in the specs, there's always some kind of reference to making sure that the concrete, mostly the whatever, say retarder, evaporation retarder, any cure, any
Right.
form release, any of those products.
Oh yeah.
You have to coordinate those, make sure it's compatible. So
Right.
there's you just concrete guys, we get all that information. We use the same list of materials every job, those materials, and we throw them all together, and then we send them on to the GC, and then GC sends them on to the architect, and the architect reviews it. And I would say they stamp it and say they looked at it, review, but then they'll put a note on there that says must be coordinated with flooring contractor. So you end up having this meeting with the flooring contractor, and you walk through all the different materials that we use, and depending on the timing of that meeting, more than likely there's already been concrete put down.
Right.
So there's already
and cured.
Product and cured. Yeah, exactly. So the concrete's already been put in place. So we're talking about something that's already occurred. And long story short, any issues with the flooring going down usually ends up somewhere on our lap at some point. But what we need to talk about is, I guess, the process.
That's actually very excellent to start with.
Yeah.
Because remember, just like when you guys go out there to place a slab on ground, the requirement for a vapor retarder, ASTM E1745 product correctly installed by ASTM E1643, that's really the prep for traditional slab on ground. That's the start. If that's done correctly, then obviously quality mix, screeded, formed, finished correctly, coming up. The surface of that concrete then becomes the substrate surface for what follows. So the things you spray on it, the evaporation retarder, the curing compound, etc., depending on how they're made, could affect what's being stuck to it. But
And
what a lot of people
and the finish too. I forgot to mention that.
Well, the finish. Okay, I remember I said I wrote. I'm the author. The finish is actually a complete aberration misnomer, where the flooring industry is blaming the concrete industry for something that is an very easy workaround. So any finishers out there, please pay attention to this point right here. One of the ASTMs I authored is called ASTM F3191. It is the measurement of the surface porosity absorption of that concrete surface. The reason why it's so important, let's say you guys get out there and you burnish the heck out of it so you can shave in it. That's a non-porous surface. And actually, I would offer to you that more than a few passes with your equipment, especially if it's a double fan out there, with just the weight, gives you a great surface, but it's going to densify that surface pace. A couple passes, it's going to be non-porous. Here's the test. It's a drop of water, 60 seconds. If it doesn't soak in, it's non-porous. The flooring industry, or some of these flooring subs, are saying, oh my God, this is terrible. We can't install on this. Not true. Because there are plenty of adhesives that will bond to a non-porous substrate. And so not only did I write the standard for the flooring industry to use, it's now a requirement for all resilient flooring to be installed, the slab surface to be pre-tested for substrate porosity. I'm also one that got that in the requirement. This is not a concrete issue, because the normal process for finishing concrete is to power trowel. It's good for you guys' labor. It's good for your amortization of equipment. It's good for just process. So most likely, new concrete is going to be non-porous. So this is actually, this is one of those process changes, that fundamental understanding that the industry needs to grapple with. Assume with new concrete, the slab will be non-porous. Even at the pre-slab, just assume it, because you're going to be using power trowels. But it's not something necessarily going to be a detriment. It just means then that the flooring installer may either have to alter, maybe have to grind the surface to open it up, or simply pick a different glue. So now go back to 1992 when they changed the glues. The VOC glues did not soak in. They dried very quickly in almost any environment. But when they went to the water-based glues, a lot of those adhesives had so much water, that water needed to go someplace. The flooring industry did not come out with substrate absorption testing in 1992. That ASTM was not published until 2016, almost 25 years later. So as a process, spreading a water-based glue on a non-porous substrate and then sealing it with a resilient flooring, you've trapped water in the concrete, or in actually the above the surface and below the backing of the flooring. So let's go back to this, how you finish. And actually, there's an article recently wrote for the Construction Specification Institute that kind of discussed this. Really, you have to assume that it's going to be non-porous. But it's not a bad thing. There are different glues that they can use. But it's an important thing for all in the project to understand. And even a lot of the slab prep materials like skim coatings, imperfections or whatever, or leveling compounds, some, if it's non-porous, simply say, oh, you got to prime it first. So it doesn't mean it's like, oh my gosh, hair fire, since you and I both bald, hair fire, run around, all this crazy stuff. No, should be fairly easily and directly being able to address without going crazy. When you and I were talking before, we talked about a 200,000 square foot project bed tower, and this is how important this is. The flooring manufacturer's spec said selected adhesive as recommended by the manufacturer. Of course, that manufacturer wants their glue used. It's another SKU. They can make a little more money. We researched it, and the glues they recommended said only for a porous substrate. If non-porous, bead blast, self-level, so you can use this kind of glue. Well, bead blasting and self-leveling is about $350 a square foot. So that the GC would have found out right at time of installation that they're looking at a $700,000 change order in extra weeks. We noted that the architect changed that language to select an adhesive suitable for substrate surface condition and compatible with flooring backing. That's part of the contract to the GC. So the GC goes, nope, we're just going to pick a different glue. That's what happened. No bead blast, no self-level unless it was messed up. All warranties conveyed, no extra charge to the project. So again, this whole thing about how the concrete's finished, that is a complete misdirection. There's lots of products that can go down on a power child concrete. Important for the concrete sub to understand as you try to support the GC and keep the project going. There's a lot of products out there. It just has to happen, some certain language in the 09 to empower the GC to just pick a different glue or pick a different underlayment. Okay, so great point. Now let's go to how it's cured. There's ASTM C309, which really is your self-dissipating compounds. They absolutely can be used safely, but the GC needs to understand that there might need to be a caveat to where the flooring contractor may have to just scuff up the surface a little bit with think about the scratch pads on the bottom of a flooring buffer that can scratch off to make sure it's all removed. Because you may not have the right UV to break it down or foot traffic or whatever. It's a quick thing that you can remove. The key, though, is it can't be petroleum-based. So you can definitely use C309 curing compounds, but you got to be careful what it's made of to make sure it can be removed. Then there's your C1315 cure and seal products. The cure and seal, if you read C1315, part of being recognized as a C1315 cure and seal is an adhesion test, a bond test. Those products have already gone through a bond test. If used properly, again, another misnomer, misunderstanding that's been pushed down by the flooring industry is that you can't use a curing compound. Well, cure and seal is permanent. It's going to go back to give you that non-porous substrate. So if it's properly applied and not puddled, where you may have some silica salts or whatever, all you do is the water drop test and then go back to what I said before. Just follow the non-porous substrate installation instructions. But why all this pressure? Why all this discussion about burnishing the concrete, or you can't use a curing seal? It has nothing to do with concrete. It has to do with the liquid products containing water, because the flooring industry was not doing porosity tests. Mm-hmm. That's what it goes back to. Improper installation instructions to completely match up with those kind of products.
So is the porous and the non-porous adhesive, is there a difference in price or something? Is that why the flooring contractor chooses?
Great question. Let's go back to people just not knowing. Because actually, the crazy thing is, there are plenty of these adhesives out there that if you look at the data sheet, it'll say literally, if the substrate is porous, use the big notch trowel and wait this amount of time.
Okay.
If non-porous, use the tiny notch trowel or a paint roller, and then do this way. Literally, there's plenty of these products that are absolutely suitable for either porous or non-porous. You just got to change which trowel or your open time. Same thing with your slab prep materials, like products, a feather finish, a skim coat that's going to, you have some scratches or whatever, and they're going to put this material and they can go on very, very thin. There's products out there that'll bond perfectly fine to a non-porous substrate. There are other manufacturers that will not, that require a bead blast or a primer, extra cost, extra time. So I can't stress enough to the design team and the general contractors to understand, just because your slab is non-porous, and it will be, does not mean you have to go down this very expensive path of bead blasting and stuff leveling. You can just pick a different glue or a different primer or a different prep material.
Yeah. So,
or just change your installation instructions for the same product.
Right. Well, before they put it down, they do a test in the field, right? What's the test?
Remember, let's go back to history. The adhesives changed in 1992. The documented process to how to evaluate substrate surface evaluation did not come in until December 2016. Mm-hmm. It became a requirement for all slabs to be evaluated July of 2021, almost 30 years after the products changed. So just think that through. How many products out there were the products simply being installed wrongly because the requirement to measure the surface absorptivity wasn't there? Think of how many things got blamed on the concrete because that simple test was not there. Let me ask you, you ever painted before? Painted drywall before?
Unfortunately, yes, I do. I do not like painting.
Yeah, you and me both. Okay, so we can look for somebody else to do it. We'll sit there and drink beer or something. Okay, simple question, silly question. What's going to take more paint, unprimed drywall or well-primed drywall?
Which is going to take less?
More. What's going to take more paint?
Oh, the unprimed.
Why? Because it's porous.
Right.
So what's going to take more glue? A porous surface, substrate concrete surface, or a non-porous?
Yeah, porous. So,
but if you spread that same amount on a non-porous, which most concrete slabs will be, you are literally installing that product wrong. Mm-hmm. And that did not become a requirement to test until July 2021. So think how many decades in between.
Have you seen on a job where a GC has required the manufacturing of the adhesive or the flooring to watch an installation?
Oh, yeah. There's another ASTM called ASTM F 3355. Or is it 3311? It's a standardized field bond test.
Mm-hmm.
Can't stress that enough. Most flooring manufacturers actually have it embedded in their literature. They either recommend or require a bond test. And the bond test is nothing more, let's say like resilient sheet. You got to do a 2 by 3 foot square foot. You prep the slab correctly. You put all the material down as if you're doing a full install. You put it down. You come back 3 days later and you pull. That's all you're doing. Often overlooked, perhaps one of the most important field evaluations that can be done. You do it for all your flooring products. Everybody stands around. They see the pull. Yep, that worked. Okay, flooring contractor, do the same thing everywhere. We shouldn't have a problem. So it's really important to do because then it's proving that, hey, there's nothing wrong with concrete. There's nothing wrong with the surface. The prep was good. Everything's compatible. So if a problem manifests later on in some other area, okay, something's different. The ambient conditions weren't right. The concrete was too cold. The product was installed differently. But more importantly, let's go back to this porous, non-porous thing. I've actually stood there and watched where an adhesive that was good for porous and non-porous, when the flooring installer was using their trowel, when they came back with their arm, they kind of overlapped. And so in certain areas, there was more adhesive than others. When they put the resilient sheet in, within a very short amount of time, as we're standing there watching, off-gassing bubbles formed. Mm-hmm. And when they peeled it back, those bubbles were directly underneath where the adhesive was double applied. And it can manifest just that quickly. So that's how important it can be depending on the glue being used. Mm-hmm. And that was at a healthcare facility that we stood there and watched it happen. And I was the one that noticed it. And I said, that's where I say back butter. They overlapped. They did it again and were very careful. Lay the flooring down, rolled it, no bubbles appeared. Had you not known what you were looking at, that easily can be blamed on concrete moisture. Mm-hmm. And it had absolutely nothing to do with the concrete. It all had to do with how that trowel was used and that particular glue and that particular flooring. But if you did not know that, that healthcare facility could have been charged $5, $6, $7 a square foot to mitigate for concrete moisture, an issue that did not exist. So, I mean, it's a big deal to know how these products are being installed and how they're supposed to be installed. And think about what you said. All this focus is on the concrete. You guys got to make sure your curing compound is suitable for the flooring industry. Who's driving all that? That all came from the flooring industry requirements. Mm-hmm. Where's the requirement to make sure they're doing what they're supposed to be doing? That doesn't exist.
I couldn't tell you because I typically don't read the flooring spec.
Well, should you, and know what I expect you to, but just understand the reason why that language is that y'all have to comply with, where it came from. Mm-hmm. That came from the flooring industry. That's where it comes from. That's where it's being driven by.
What's the moisture content requirement? Where does that stem from? Because I know over the last handful of years, some of the companies that sell the maturation meters. You
the probes for temperature, the probes for hydration.
Yeah, right. I forgot which company it was. One or two of those companies were trying to sell you that, hey, this also measures the moisture content of the concrete. So
the internal
yeah,
RH.
Yeah, so when it's okay to put the flooring down. And I had maybe one GC reach out when we were looking at a particular job, and they said, hey, could you look and see if this is something we should use?
Well, okay. Again, the devil's in the details. So ACI, American Concrete Institute, there's a document, there's a guide for the design of concrete slabs to receive moisture sensitive flooring. ACI 302.2. Pretty specific document, right? I mean, that is the guide for the design of these kind of slabs, roofing, flooring, right? In that document, and the first iteration of that document is 2006. It just got reviewed. I think the new iteration is coming out for 2022. It says very clearly there is no relationship between the RH of the concrete and the adhesion of resilient flooring. So then why is there such a big thrust to worry about the RH of the concrete? Which industry came up with that test?
Well, not the concrete guy, I can tell you that.
Not the concrete guy. So if it wasn't the concrete guy, who came up with that test?
The flooring guy, but yeah, I don't understand. Again, are they just trying to mitigate any liability?
Well, I told you when we talked before, I actually did my doctoral dissertation on this subject, and it went a lot through a literature review to try to deconstruct the process of whether or not testing for moisture before you install flooring or roofing is actually a value add process. Does it really lead to what the design, build, owner communities believe it does? And if you go back again to 1992, they changed the glues, massive failures. I would postulate, and I don't think I'm wrong, is that a lot of those failures were predicated on trying to use a water-based glue in the same manner they used VOC adhesives. And a VOC-laden adhesive, you can put down in 98% humidity, high temp, low temp, it's still going to cure properly. The water-based adhesive, absolutely not. And so if you follow the timeline, those changes occurred in 92. The requirement to moisture test came from the flooring industry, and that became codified in 1998. Which is also the first year that the flooring industry codified the calcium chloride test as an ASTM. 4 years later, 2002, the RH test became a codified ASTM. So the timeline is important. The glues changed. Concrete didn't change. Mm-hmm. Massive failures occurred. The flooring industry, or the concrete industry, was oblivious because y'all were just doing y'all's thing. But on the flooring side, the flooring industry turned and drew attention to the concrete and did not draw attention to the adhesive changed and installation instructions not changing. So these two tests became codified. And so by the same token, every spec you go through and you see that it's a requirement to make sure that the curing compound is compatible, or gosh forbid, the surface of the concrete, how it's finished, is compatible with what's going to be installed. On the flooring side, they got driven into every single flooring spec, the requirement the concrete be tested for moisture. Mm-hmm. So that requirement was driven by the flooring industry, not by the concrete industry, using tests written and overseen by the flooring industry, not the concrete industry, driven through the spec, and now it's endemic in every single project out there. Just like what you see on the concrete side, there's certain things you see in every spec. Moisture testing is in every flooring spec. But again, it's important to understand, where did that process come from? It originated out of the failures in the 90s that the flooring industry was faced with by changes they made, not the concrete industry. But somehow they got to focus on the concrete, not on their products. The insidious thing is, if you dive deep into the tests themselves, the calcium chloride test and the RH test, the standards are very clear. The results are only valid at the time of the test. No flooring. Water-based adhesive. water-based cementitious prep material. So you had this dry surface, then you spread some liquid on it. That's obviously going to change the moisture content. Then you cover it with an impervious flooring cover. So if it does fail in the future, what the flooring industry is going to do is come in and test that for moisture. Obviously going to be higher. And they're going to say, oh, it's from the concrete. Wait a second. All you're telling me is the moisture content changed, but that doesn't tell me where the moisture came from.
Mm-hmm.
Nobody talks about that. And then the last comment, if you play it through, one of the biggest points that the flooring industry has used to get this embedded into every single spec is this threat that if you don't pass the moisture test, you can't get the warranty. All any designer or GC needs to do is simply look at the warranty from that manufacturer. Manufacturers warrant manufacturing defect. In almost in all cases, they have what's called exclusions. Very clear. Moisture is always excluded. So to wrap all that up, the glues changed because of EPA VOC requirements. Mm-hmm. The installation instruction did not. Massive failures. The flooring industry came up with a requirement to test in 98. The flooring industry came up with the test methods in 98 and 2002. The flooring industry has since evolved to threaten that if you don't pass these tests, you can't get a warranty, all for an issue that if you read the warranty is not covered. You got it. You laughed. There you go. It is all laid out. That's the current process that it's like a dog chasing its tail. The GCs. And I mean, we can go into other things too. There's literature out there that most likely the concrete cannot even pass this test. I mentioned before, there's literature out there, ACI literature, that the tests aren't even related to adhesion. So most likely the concrete cannot pass, not related to adhesion, and not covered by a warranty. So mm-hmm. the bigger question is for your audience base should be, well, why are we doing this process?
We can ask, but more than likely we won't change the process. So what can we do as contractors and suppliers?
Well, I would offer you change it by one at a time. And what we do is we provide a path that the projects can change that process. So if our product goes in the concrete, so we're going to compare this to a regular project. You're a baker, you're there on site, concrete trucks come in. As far as you're concerned, there's no difference. The truck pulls up, we're there. The solution's already there. Or you may have a project, and we call it the tale of two projects, or our product's not there, and then the project has to go through everything we just described. Mm-hmm. Well, if our product's there, the process is already changed. Because what the project team can do is they can go into the flooring spec and they can remove the requirement to moisture test. The project documents are written and driven by the architect and the consultants. They're not written and driven by the manufacturer. That's based on the legal general conditions. The architect and their consultants, they decide, not the manufacturer. And that's one of those little things that keeps getting missed. So if done correctly, you take a product like ours and you put it in the 03 spec so that you guys know it's there, the ready-mix producer knows it's there. But concurrently, you go into the 09 spec and remove the requirement to moisture test. Why? Because you've already picked a solution that's warranted 100%. Once that's done, now the process goes through. You all do your work, you finish it, you whatever. Then the GC can actually send to us the entire flooring submittal. And all these things we talked about, is porosity an issue? Are ambient conditions an issue? Is adhesion an issue? We review that for the project. And we put it in writing to include, by the way, to include curing compounds.
But getting away from that process that's in the specifications, does that not void that warranty that we, I guess, through our discussion on this podcast, doesn't hold any water? Actually, no pun intended.
There's a funny thing too about a spec. If you look at a lot of different product specs in part one, because these are 3-part specs, in part one, the architect can simply add 1.8 warranty. Standard manufacturing defect warranty shall convey. It's a contract document now.
Right. But if it sounds like the warranties that are out there are pretty much null and void because no one's really following what it says anyway. So what we're saying is,
but it's manufacturing defect.
Right. But what I'm getting at is, I think people need to get over the fact that this warranty is there, but it's not really doing anything for you. So
unless the manufacturer made the product wrong.
Right. But what we're saying is we need to start thinking about solutions that provide a superior result or superior Product at the end where you don't have problems and you don't need to use a warranty. So there's what pops in my, I don't know if you ever seen the movie Tommy Boy talks about the warranty. That popped in my head. So
Sandusky, Ohio, right? Wasn't that Sandusky or
yeah, right.
Yeah.
So he tells you about what he thinks about warranties. It's quite hilarious. But anyways, so
probably can't repeat that here.
No, well, we could, but then I have to change things on all these podcasts. Anyhow, so what we're saying is we need to stop jumping through all these hoops to make what we think we're applying or we're following the orders of the warranty. We are doing what the warranty is asking us. At least we thought we were.
We thought we were, yes.
Yeah. So what we need to think about is how do we deliver a product that will function and do what it's supposed to do at the end of the job so we don't have to worry about the damn warranty.
Correct.
That's what we're getting at. So what you're saying is your company will review all the specs and the documents, the submittals and in there and suggest a solution that provides a result that everyone can be happy with. The owner's happy. You don't have floors bubbling up. You don't have adhesive not doing what it's supposed to do. That's what we're driving at today. That's what we need to start looking at. And that not only applies to what you do, Dean, but also applies to a lot of things that we do as a concrete industry across the board. We're all jumping through hoops to make someone happy that's written something down that we think we're doing ourselves good.
Well, correct. And so with the warranty thing and the process thing, first of all, if you're anybody ever, whether it's in your own personal life or whatever, if somebody starts threatening a warranty, you might want to go pull the warranty out and read it. Because again, the flooring manufacturer warranty, you may get some labor or whatever, but it only applies, their warranty only kicks in if there's a manufacturing defect. That's when their warranty kicks in. So whether you take that flooring product and install it correctly, or whether you put it in the bottom of your parakeet cage, that's what they cover. Now, if it fails in the bottom of your parakeet cage, they're like, well, that's not the intended use. You can put it in your parking lot and drive all over it. Hey, the flooring all tore up. They're going to come out there and say, not intended use.
Mm-hmm.
But they weren't manufacturing defect. And they're going to say, yeah, it looks terrible. It's all torn up. But we didn't make it that way. That's what they warrant. So the simple question is, why are projects allowing themselves to jump to those hoops, chase the mythical unicorn of a past moisture test for an issue that's actually not covered?
Mm-hmm.
Step back and just slow down and say, okay, looking from the owner's perspective, and this goes back to what you were saying about delivered that quality product, but floor's not bubbling, etc. What does the owner want? And I've done this before. I asked, does the owner want a passing RH test, or does the owner want what you said, that floor delivered on time, on budget, and that performs the way it's supposed to? I would offer the owner wants the second one.
And
low maintenance, that goes to the product selection. Correct.
Yeah.
Right. That's what the owner wants. And too often people say, well, I have to have the low RH. No, wait. Which one do you want? Well, I want the second one. Okay, that's easily achievable. That is definitely achievable. But if you keep thinking that you have to chase this metric that's not even tied to that, ACI says it's not tied to it. The flooring industry itself says there's no warranty for it. The test itself tells you it's only point in time. And crazily enough, we mentioned the RH test. The RH probe is less than the diameter of a quarter. And its test is 1 per 1,000 square feet. Okay? Okay, I'm glad you're laughing. So the test says it's only valid for the exact location of the test. So the room you're in right now is way less than 1,000 square feet, but just put a quarter down there and look at all the other area that's not being tested. So just from a rational perspective, how then is that quarter relevant to the 99.999% of the substrate surface that's not being tested? But that's what's written. Point in time, the exact location. So think that through. By the plain language of the ASTM document that you're chasing, unless that failure occurs right above that quarter, then the simple out for the flooring industry, well, that area wasn't tested. Read the documents. It says very clearly. And then read the warranty. There's no warranty, exclusion, blah, 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 moisture.
Yeah.
So again, if once people understand that, they can be doing this as well as rolling the dice or flipping a coin or doing a divining rod. But make the manufacturer warrant that they made their product correctly. That's easily put into a spec.
Mm-hmm.
Manufacturing defect, that's the Uniform Commercial Code. Try to allow a manufacturer circumvent that they made their product correctly by what you do with it on your project. Those aren't associated.
Mm-hmm.
It's not rocket science, but it's just, everybody slow down, stop chasing, jumping through hoops, and just say, wait a second. You look at all the documents together. If we go to if we enter this process here, we're not coming out where we think we are. And that's why this keeps perpetuating, because people aren't slowing down and stepping back and just simply looking at the documents that it's based on. And therefore, they keep going through this. But I can tell you right now, you change this process, it fundamentally alters project delivery. We did a massive project. You mentioned Ohio. We did a project just out of Columbus several years ago. The GC evaluated the inclusion of our admixture, and following this process, saved about 3 months in the construction process. You used to be at a design build. I know you're a banker. What do you think the value is to that owner in GC by shaving off 3 months in the construction process on a 600,000 square foot hospital?
Got to get those butts in the beds to make money. So
there you go.
Yeah.
Now, I'm not saying they didn't lose that someplace else, but 3 months, and that 3 months was associated with testing, waiting for the results, retesting, meetings, and then mitigating.
Right.
By simply changing the process. By the way, all warranties conveyed. They got their manufacturer's warranty, they got the installer's warranty, they got a warranty against moisture from us, and they got an adhesion warranty from us. By simply changing the process.
Yep. So that's how the concrete producers and contractors can help these GCs and owners out.
Absolutely. And in fact, you mentioned the producers. A lot of the producers, CIP, shout out to NRMCA, the Concrete in Practice, the simple documents, the 2-page documents, like 1 through 5 is for cracking. CIP 28 from the National Ready Mix Concrete Association is called Concrete Moisture. In that document is actually listed as a moisture vapor reduction admixture is one way that the concrete industry can offer up a proactive way to address this issue, as opposed to not being involved, not benefiting, not getting paid for a issue that is concrete issue and leaving it for after the fact for the flooring industry. So absolutely, this is absolutely a way for the concrete industry to to be a part of a proactive solution in support of the GC, in support of the owner, as opposed to leaving this to an industry that's completely disassociated.
Right. And that's the key. I think the key word there is proactive. So that's something that we struggle with all the time. So let's give that a go. Dean, I think Dean, let's pause it for today. If folks want to reach out to you and learn more about your company and your product, what's the best way?
You can go to our website, iselogik.com. You can go to contact. My name is right there. I'm one of the principals. I'm one of the owners. I sign all our warranties. You can reach out to me. They can find me through you. And I'm letting right now, I'm fully authorized, Seth, to share my contact info. So don't mind at all. If you have an organization that wants us to come in and talk, we routinely have lunch and learns is one thing, but we also have more focused project delivery discussions directly with GCs, design build. So if you want us to come in, we're more than happy to. But I guess the easiest way, since people know who you are, I fully authorize you to share my information. Otherwise, go to our website, and we'll be happy to help however we can.
Yeah, so when we release this, we'll put your info on the show notes, and people
Absolutely,
will have access.
Please do.
We also have if you all aren't part of our newsletter group, you can go to concretelogicpodcast.com and sign up for our newsletter. We got a bunch of folks that get our weekly newsletter too. So we'll get you on that list, Dean, and then others that are listening, please do that as well. Dean, I appreciate coming on the show today, and I hope we do it again soon.
Sure. Thanks, Seth. Enjoyed it. Thank you so much.